So today we are going to learn about exponential functions, and we're going to be graphing them. So today we're going to be graphing them, and we're going to notice where the asymptotes are. Okay, so the exponential function looks like this, where b is your base. B is the base. And I'm just going to draw an arrow to the A. A is your y-intercept. Okay, all right, so we're going to go ahead and graph this first one. I'm going to make a table right here. And we're going to plug in x values into this exponential function. So I'm going to plug in a -3, a -2, -1, 0, 1, 2, 3. We'll just plug those numbers in. So when I plug it in, the bases are all 2, but that exponent is going to change. I'm going to plug in a -3, a -2, all of these numbers. Okay, so I'm going to start in the middle. Anything to the power of 0 is 1. So 2 to the power of 0 is 1. Anything to the power of 1 is just itself. And we all know 2 squared, that's just 4. And 2 cubed, that means 2 times 2, which is 4, times another 2, which is 8. Okay, and now let's go down to the negative sides. Now we have to recall a rule that we learned last unit. Whenever you have a negative exponent, you can make it positive by putting it into the denominator. So basically flipping it, okay? So we're going to put this as 1 over 2 to the 1, which gives us 1/2. This one will be 1 over 2 squared, which is 1/4. So guys, basically 2 squared is 4, and then put it in the denominator. 2 cubed is 8, put it in the denominator. So guys, y'all notice how 3 will give you 8, but -3 will give you 1 over 8. 2 will give you 4, but -2 will give you 1 over 4. Okay. All right, let's go ahead and graph these points. My first point is -3 and 1/8. So let's go over to -3. It's very small, very close to 0. -2 and 1/4, that's also very close to 0. -1.5. 0, 1, 1, 2, 2, 4, and 3, 8. All right, so this is my graph. Now, guys, if I plugged in more points, like say I plugged in a 4, what's 2 to the 4th power? 16. If I plugged in a 5, 2 to the 5th power, 32. So if I plugged in a -5, that would be 1 over 32. That's also very small. So guys, as you move to the negative sides, you'll get very close to 0, but you won't actually touch 0. Do you guys remember what this is called? An asymptote. So guys, your asymptote is right here. It will get very close to this line, but it will not actually equal 0. The x-axis, yes. It's the x-axis, but we're going to call it y equals 0 since it crosses the y-axis at 0. But yes, it is the x-axis in this case, okay? So the asymptote here is y equals 0. It'll get very close to that line, but it will never touch it. Okay, so guys, this is the exponential parent function. It didn't move up, down, left, or right. It's just the basic function, okay? Now, let's go ahead and graph it with a different base. This time, our base is 1/2. So let's see how our graph will look differently. So I'm going to erase this. You guys should already have this table written. I need more space on here. Okay, so let's make a table again. You can do it on the right side of your paper. Y'all have space. Y'all can do it over there. Okay, so now I'm gonna plug in the same things. -3, -2, -1, 0, 1, 2, 3. And this time it'll be 1/2 to the -3rd power. 1/2 to the -2 power. 1/2 to the -1. Okay, now let's deal with these negative exponents. Whenever you have a negative exponent, do the reciprocal to make it positive. So we'll write this as 2/1 to make that a positive exponent. To make this one a +2, flip it, it'll be 2/1. To make this a +1 exponent, flip it, make it 2/1. What is anything to the 0 power? 1. Anything to the first power? Itself, so just 1/2. And this will be 1/4 because 1 squared is 1, 2 squared is 4. Okay, let's figure out these. 2 times 2 is 4, times 1/3 2 is 8. 2 times 2, this would be 4, and 2 times, well, it's just 2. Anything to the first power is just itself. Okay. Just for fun, if I plugged in a -4, it would be 1/2 to the -4th power. To make it a +4th power, we flip the fraction. So what would this become? 16. And then over here, if I plugged in a +4, it would, oh, we skipped 3. Let's plug in a 3. Oh, erase that. So if we plug in a 3 here, it will be 1/8. Okay, so let's just go ahead and fill out our table. Fill out our graph. We have our table. I'll do it in purple. I kind of wrote all over my graph. But the point -3/8 is right up here. That's -3/8. -2/4 is right here. -1/2 is there. 0/1. And notice, guys, it's going to get very close to my asymptote, but never touch it. It's going to get very close to 0. 1 and 1/2. 2 and 1/4. 3 and 1/8. This is going to continue getting smaller and smaller, getting close to 0. So that is our graph. So what we have to notice is when A is greater than 0 and B is greater than 1, basically your base is a number that's bigger than 1, your function is going to be increasing. This is called exponential growth. Okay? So whenever your B value right here, if it's greater than 1, you're going to have a growth graph. If your B value, like this 1/2, is less than 1, they're saying between 0 and 1. So we're not talking about negative numbers. Just between 0 and 1, it'll be decreasing, and we'll call it exponential decay. Okay? All right, so that's how you know if you have something that's growth or decay. You look at the base. All right, so let's look at another example. Let's do this one. And guys, I want us to make this a little bit more harder. So everyone fix this. We're going to put a +1 right here and a -3. Add that to your equation. And we'll continue making a graph. So I'm going to make a table. We're going to plug in x values. So let's plug in a -4. Let's see what happens when I plug in a -4. So this is my equation, 2/5. I'm going to plug in a -4 up here, right? What will this become up here, this exponent, if I plug in a -4? Yep, -4 plus 1 is -3. So if I plug in a -4, this whole thing becomes a -3. And what do I do? Yep, it'll become 5/2 to the third power to make this a positive exponent. Then we'll subtract 3. So let's evaluate this. What is 5 times 5 times 5? 125. And what is 2 times 2 times 2? 8. Whatever this number is, can you guys put this in your calculator? What's 125 divided by 8? 15.6. Okay. So we're going to have 15.6 and we have to subtract 3. So what would that be? 12.6. There we go. We're still plugging in numbers and finding our y value. Okay, next, let's plug in a -3 this time. So I'll walk you through this process. Okay, so now we're going to plug in a -3. So if I plug in a -3 here, what's -3 plus 1? -2. Okay, so that becomes a -2. And then we are going to have to flip this fraction to make this exponent +2. And we have to ask ourselves, what's 5 times 5? 25. 2 times 2. Okay, can you guys figure out what this is as a decimal? 25. 6.25. Thank you. And subtract 3. So this will become 3.25. Okay. Let's plug in, I'm just going to skip some stuff. Let's do 0. If I plug in 0, let's see what happens. So now I'm going to try to plug in 0. So I plug in a 0 here. So what will this become? 1, so it'll just be 2/5 minus 3. Can someone tell me what 2/5 is as a decimal? 0.4. Minus 3 is what? -2.6. Okay. Now let's plug in a 2. Let's plug in a 2. Let's see what happens. All right. I'll plug in a 2 here. Okay, so this will become 2/5 to the third power. So this will become 8/125. And then we're going to subtract 3. So what is 8 divided by 125? 0.064. And then we have to subtract 3. -2.9. Perfect. What number does it look like we're approaching when you look at this one and this one? Yeah, we're approaching -3. Do you guys see the significance of the equation? What do y'all notice?
The increments are getting smaller.
It is getting smaller. This number right here determines your asymptote. So as we plug in more numbers, you're going to get very close to -3, but you won't touch it. Okay. All right, so let's go ahead and plot these points on our graph. At -4, you're up here at 12. 1, 2, 3, 4, 5. You're up here somewhere. Okay, -3 and 3.25, you're about right there. And then 0, -2.6, you're about right there. And then at 2, you're at -2.9, you're right there. So this is how your graph is looking. You're going to get very close to the -3. So let's talk about the domain and range. Your domain, it goes forever to the left, forever to the right. It's all real numbers. It will always be all real numbers for every exponential graph you see. However, your range, where is the very bottom? -3. Yes, it's approaching -3. And then it goes up from there, so infinity. Everything is above -3. You can also write it as y is greater than -3. Now let's look at the end behavior. Let me use a different color so we can see. As my x values go this way, what's happening to the graph? It gets lower to what? Yep. Does it go down here to negative infinity? Yep, it just stays at -3. It gets closer and closer to -3, but it doesn't touch it. You'll get 2.999, 2.99999. Just get closer and closer to -3. Okay, next, as my x values go this way, what's happening to the graph? Yep, it's going to infinity. So guys, our end behavior is different this unit. You will be approaching an asymptote, not infinity. Okay, here we approached an asymptote. Okay, the y-intercept. It looks like it crossed at right here, -2.6. 0, -2.6. And your asymptote is at -3. So let me draw that for you. This is the line that your graph will get closer and closer to, but never touch. This dashed line that I drew, that's the y-axis at -3. It crosses the y-axis right here at -3. So that is what you put for the asymptote. Your asymptote is always this number here. So notice in our previous examples, we didn't have a plus anything. You can just imagine a +0. That's why your asymptote was at 0. But if your graph moves up or down, your asymptote changes. Okay? So guys, if you think about what we always do for every unit, the transformations, this is what your transformations will look like. This number determines if it goes up or down, and that tells you what your asymptote will be. So please write that down off to the side.